In the vast expanse of the cosmos, amidst swirling galaxies and fiery stars, there exists a fundamental truth. Matter is neither created nor destroyed. This simple yet profound statement forms the bedrock of the law of conservation of mass, a principle that revolutionized our understanding of the physical world. For centuries, alchemists toiled away, convinced they could transmute base metals into gold, all the while operating under the misconception that matter could simply vanish or appear at will. It wasn't until the 18th century that a brilliant French chemist named Antoine Lavoisier, armed with meticulous experimentation and an insatiable curiosity, shattered this misconception. His groundbreaking work established a fundamental truth. In any chemical reaction, the total mass of the reactants before the reaction is always equal to the total mass of the products after the reaction. This realization sent shockwaves through the scientific community, ushering in a new era of chemical understanding. No longer could matter simply disappear into thin air or materialize from nothing. The universe, it seemed, played by a strict set of rules, with matter constantly shifting and changing forms, but always remaining constant in its total amount. Born into a wealthy Parisian family in 1743, Antoine Lavoisier was a man of diverse talents. Trained as a lawyer, his true passion lay in the realm of science. Lavoisier's meticulous approach to experimentation set him apart from his contemporaries. He meticulously measured and recorded every detail of his experiments, ensuring their accuracy and reproducibility. One of Lavoisier's most significant contributions was his meticulous study of combustion. At the time, the prevailing theory, known as the phlogiston theory, posited that a fire-like element called phlogiston was released during burning. Lavoisier's experiments, however, revealed that combustion was actually a chemical reaction involving oxygen. He demonstrated that when substances burned, they combined with oxygen from the air, resulting in an increase in mass. This groundbreaking discovery not only debunked the phlogiston theory, but also solidified Lavoisier's place in scientific history as the father of modern chemistry. His meticulous approach to experimentation and his emphasis on quantitative analysis laid the foundation for modern chemical practice. The law of conservation of mass is not merely an abstract concept confined to textbooks and laboratories. It's a fundamental principle that governs countless everyday phenomena. Consider the simple act of burning a candle. As the candle wax melts and the wick burns, it may seem like matter is disappearing. However, if we were to capture all the products of combustion, the carbon dioxide, water vapor and other gases, and measure their mass, we would find that it equals the mass of the consumed wax and oxygen. Even in seemingly complex processes, like the growth of a tree, the law of conservation of mass holds true. A tree grows by absorbing carbon dioxide from the air, water from the soil and sunlight. These reactants are transformed through the process of photosynthesis into complex organic molecules that make up the tree's wood, leaves and roots. The total mass of the tree and the oxygen it releases during photosynthesis is equal to the mass of the carbon dioxide, water and sunlight it consumed. Section 4. From Combustion to Cosmology, Applications of the Law. The law of conservation of mass has far-reaching implications, extending beyond the realm of chemistry to influence diverse fields like ecology, engineering, and even cosmology. In ecology, this law underpins our understanding of nutrient cycles. For instance, the carbon cycle illustrates how carbon atoms are constantly exchanged between the atmosphere, oceans, living organisms, and the Earth's crust. While the form of carbon may change, from carbon dioxide in the atmosphere to organic molecules in plants to fossil fuels buried underground, the total amount of carbon on Earth remains relatively constant. This principle is crucial for understanding the delicate balance of ecosystems and the potential impacts of human activities on the environment. In engineering, the law of conservation of mass is indispensable for designing and optimizing chemical processes. Chemical engineers rely on this principle to calculate the exact quantities of reactants needed to produce a desired amount of product, minimizing waste and maximizing efficiency. Section 5. a lasting legacy. More than 2 centuries after Lavoisier's groundbreaking work, the law of conservation of mass remains a cornerstone of modern science. It serves as a testament to the power of meticulous observation, rigorous experimentation, and the human desire to comprehend the universe's intricate workings. This fundamental principle continues to shape our understanding of the world, from the smallest chemical reactions to the grand cycles of matter and energy that govern our planet. As we delve deeper into the mysteries of the universe, from the subatomic realm to the vast expanse of space, the law of conservation of mass stands as an enduring beacon of scientific truth. It reminds us that even in a universe of constant change, some things remain eternal and unchanging, the fundamental laws that govern the very fabric of existence.